What if I told you there's a planet rolling through space on its side, wearing a blue-green glow and colder than anywhere else in the solar system? That's Uranus. I reckon many of you have heard the name but don't really know much about it. Today, let's explore the seventh planet from the Sun together. Stick around till the end. I'll show you how to spot Uranus with your own eyes. So buckle up, we're going full throttle straight to Uranus. Let's go. The discovery of Uranus is legendary stuff. In 1781, British astronomer William Herschel spotted this planet using a telescope he built himself. It was also the first planet in human history discovered through a telescope. Before this, ancient people could only see Mercury, Venus, Mars, Jupiter, and Saturn with the naked eye. Uranus completely changed how we understood our solar system and the universe. Suddenly we realized the universe was massive. There was actually another planet beyond Saturn that we couldn't even see. Uranus sits about 2.87 billion kilometers from the Sun. That's about 19 times farther from the Sun than Earth. So far, that sunlight takes nearly 3 hours to get there. Its orbital period is a whopping 84 years, meaning Uranus takes one trip around the Sun while Earth completes 84 orbits. Its volume is roughly 63 times Earth's, but its mass is only about 14.5 times heavier. Its density ranges between 1.27 to 1.3, just slightly heavier than the human body. Uranus has a truly unique color. It appears blue-green because its atmosphere contains about 2% methane. That 2% methane acts like an optical filter. It absorbs red light and some green light from the Sun, then scatters and reflects blue light plus the remaining green light. This atmospheric chemistry creates that distinctive blue-green appearance we see. Besides methane, Uranus's atmosphere is mainly 83% hydrogen and 15% helium. The atmosphere is incredibly thick with a complex structure. Thanks to the Hubble telescope and Voyager 2, we discovered that Uranus spins ridiculously fast. One rotation takes just 17 hours and 14 minutes, much faster than Earth. This high-speed rotation, combined with its extreme axial tilt, creates fierce storms in Uranus's atmosphere. Wind speeds can hit 900 kilometers per hour. For comparison, Earth's highest recorded tornado wind speed was 513 kilometers per hour in Oklahoma back in 1999, while natural wind speeds max out around 372 kilometers per hour. Here's where Uranus gets really weird. It's the only planet among the 8 that's literally lying on its side. Why do I say lying down? Most planets have slightly tilted rotation axes. Earth's is 23.5 degrees. But Uranus, a massive 97.8 degrees, almost parallel to its orbital plane. Basically, Uranus is rolling through the solar system like a ball. This bizarre orientation creates extreme seasonal changes. Each pole experiences 42 years of continuous daylight followed by 42 years of darkness. That's downright mind-boggling. What caused such an extreme tilt? Scientists reckon Uranus suffered a massive collision long ago that knocked its rotation axis sideways. Based on calculations, the impacting object would need to be about Earth-size to create Uranus's current state. But that's just theory. We don't have solid proof yet. Still, this quirky orientation definitely makes Uranus stand out. Now let's check out Uranus's ring system. Many people think only Saturn has beautiful rings, but Uranus has them too. It was the second planet discovered to have rings, after Saturn. In 1977, scientists were observing a star when Uranus blocked their view, and they accidentally discovered the rings. So far, we've found 13 rings around Uranus, mainly composed of rocks and ice particles. Unlike Saturn's bright, dazzling rings, Uranus's rings are more subtle, only visible under specific lighting conditions. Uranus also has plenty of moons, 27 known so far. Their names mostly come from Shakespeare and Pope's literary works: Miranda, Ariel, Umbriel, Titania, and Oberon. Titania and Oberon are Uranus's largest moons, with surfaces covered in thick ice layers. Actually, among these 5 major moons, 4 have varying degrees of ice layers and subsurface oceans, all except Miranda. Even Miranda, with just a 472-kilometer diameter and weak heat retention, might still have ice layers or underground water thanks to orbital resonance and tidal stretching. Uranus's magnetic field is completely different from Earth's or Jupiter's. Instead of originating from the planet's center, it's offset by about 1/3 of the planet's radius. This creates a highly asymmetric magnetic field with magnetic poles tilted 59 degrees from the rotation axis. This magnetic structure is absolutely unique in our solar system. It's got scientists fascinated about Uranus's internal structure. The magnetic field strength is about 75% of Earth's, but because of this weird structure, Uranus's auroras are unlike anything else. They appear at different latitudes, creating strange light bands. Speaking of internal structure, Uranus is classified as an ice giant, different from gas giants like Jupiter and Saturn. Let me explain. Traditionally, Uranus gets lumped with Saturn, Jupiter, and Neptune as gas giants because they all lack solid surfaces and have outer layers mainly of hydrogen and helium. But modern astronomy classifies Uranus as an ice giant based on compositional differences. The key difference? Gas giants have cores mainly of liquid metallic hydrogen and helium with higher gas ratios. Ice giants lack clear solid surfaces but have high density ice mantles. Models suggest Uranus has a dense rocky metallic core, but most of its mass concentrates in an ice rock mixed mantle. The ice giant classification comes from this ice mantle's dominant role. This isn't everyday ice though. It's high density matter formed under extreme pressure and low temperatures, mainly water ice, ammonia ice, and methane ice. Scientists think Uranus might experience diamond rain. Under high pressure, methane breaks down and carbon atoms cluster into diamond particles that slowly sink toward the planet's depths like raindrops. While unconfirmed, theoretical models and lab simulations support this fascinating possibility. Uranus is absolutely freezing, the coldest planet in our solar system, hands down. Its upper atmosphere can drop to minus 224 degrees Celsius, nearly absolute zero. Although Uranus is far from the Sun, it cools faster than even more distant Neptune. This puzzles scientists. The rapid cooling might relate to its unique axial tilt and internal structure, or perhaps early violent impacts caused massive internal heat loss. Human observation of Uranus has been limited. Since Herschel's discovery, we've never stopped studying it, but only NASA's Voyager 2 has actually visited Uranus, flying past in 1986. It sent back loads of precious data and photos, giving us our first close look at Uranus's rings, moons, and atmosphere. Though Voyager 2's flyby was brief, it discovered 2 new rings, 11 new moons, and confirmed Uranus's extremely low temperatures. But this information barely scratches the surface. There's so much more to explore. Uranus's discovery gave humanity new understanding about planets. Its unique rotation, extreme climate, complex magnetic field, and mysterious internal structure opened new doors for scientific research. Maybe someday when humans can visit Uranus, we might harness its extreme cold and diamond rain for our benefit. Finally, Starweaver will teach you how to spot Uranus yourself. You'll need a telescope with at least an 80mm refractor. This will show a tiny blue-green disk. If your budget allows, a 150mm reflector works even better, paired with 200 by magnification eyepieces. The best viewing time is around November each year during Uranus's opposition. In 2025, opposition occurs on November 21st. That's when Uranus is brightest and closest to Earth. During opposition, when the sun sets in the west, Uranus rises in the east, reaches its highest point at midnight, then sets at dawn. Taking Sydney as an example, about an hour after sunset, point your telescope toward the northeastern horizon, looking about 30 to 40 degrees above the horizon. That's where you'll find it. Uranus will be in the constellation Taurus, sitting just south of the famous Pleiades star cluster. If you can't locate it, just ask an AI app for Uranus's real-time position. If you're feeling energetic, midnight is ideal because the atmosphere is most stable with minimal interference, giving the clearest views. Oh, and don't try this from the city. Light pollution will seriously mess with your viewing experience. Choose somewhere high and open. A mountaintop or open farmland works brilliantly. Best of luck spotting this beautiful planet, mates. This is Cosmic Canvas. I'm Starweaver. If you love space exploration and cosmic mysteries, hit that like button and subscribe. Next up, Neptune, the windiest, stormiest world you've never imagined. You won't want to miss it. See you next time. Love you all. Bye.